Hi, this is Dana with GMAT Ninja, and today I'm going to be talking through table analysis questions for the data insights portion of the GMAT Focus exam. So these questions are essentially like Excel questions, right? You're going to get some kind of sortable chart on the screen, and they're going to ask you some questions about that. So most people have worked with Excel or with Google Sheets in work or in school. This is basically just doing that. In this video, we're going to start with some medium-ish questions and then do a little bit of a harder one at the end. We're just kind of talking basic approach of how to do well on these particular kinds of questions. So for that approach, pretty standard stuff. But first thing is that you want to give yourself time to really see what that table is giving you in terms of information, right? So if there is a title, take the time to read that. Usually there's a chunk of text that gives you a little bit of context about the table as well, so read the text. And then finally, just orient yourself to the chart itself, see kind of what columns you're dealing with, what rows, before you dive into those questions, really kind of know what you're working with. Second thing is that sorting is your friend. There's going to be clickable arrows on the top of the chart that allow you to sort that information in different ways. And that kind of thing can make it much, much easier to answer a given question. So just know that that is available to you and that most of the time it's going to come in handy. Sometimes you may need to sort in multiple different ways, right? So you might start out the question sorting it one way, use some information that you glean that way, and then for the rest of the question, maybe you sort it in a different way. So just remain flexible. You've got lots of different ways that you can sort the chart, and you might need to do multiple ways for one question. Sometimes there is quant involved, so usually not too heavy on the quant side, but there might be some stats concepts that come up, that kind of thing. So just make sure that you think it through before you dive into the question. And then finally, probably most importantly, pay attention to the details, right? So that's the details in the data, that's the details in the question. Most of the errors that people tend to make on questions like this are not because they don't understand the chart. It's because they miss some piece of information by just reading too quickly or something like that. So give yourself time to be careful and deliberate as you answer these questions, just like you would on any other GMAT question. So what I will do is I'll go ahead and give you a couple of minutes to work through the first question. I'll put a link up on the screen and then also in the video description. That's so that you have access to that sortable chart and you can work through it just like you will on the test on test day. So after you work through that, then we will come back and we will talk through the solution. So I will go ahead and put that on the board now. And as always, if you need more time to think that one through, go ahead and pause the video and take as much time as you need, and then we will talk about it. So starting with orienting ourselves to this chart, here we have some text in the bottom. That's where I'm going to start. That tells us that the table summarizes information about these 9 stores in a small grocery chain. The second sentence is really useful. The table includes chain-wide averages where appropriate. So what that tells us is that in that bottom column, we have those averages already calculated out for us, which is really helpful, might save us some number crunching on particular questions. So definitely good to note that those averages are already there. Looking at the chart itself, we just have these stores. They're called A through I. And then we get these various data points about them in terms of types of lanes they have, types of amenities they offer, and then this average customer age in those stores. Pretty straightforward. So now that we understand what the chart is telling us, let's go ahead and look at these true-false questions. The first one says, true or false, in each store whose customer average age falls between 34 and 36, the number of self-check express lanes is above average. So here we've got 2 of these columns mentioned, right? We've got our average customer age, and then we've got the self-check express lane number. And then we're also dealing with this average that is provided at the bottom of that latter column. So in terms of how to sort this, to me, it makes sense to sort by age so that we can see which stores fall within this range, and then we can go ahead and compare the number of lanes compared to the overall average. So let's go ahead and do that. All right, now our chart is sorted for age, which with the lower ages on top going all the way down to our higher ages. And we're looking particularly for the stores that fall between 34 and 36. And if we do that, you can see it's just the 2 stores, store A and store F, that fall within that range. So now in those same rows, just kind of going over to the side, how many self-check express lanes do they have? Well, you can see that they each have 8. And then how does that compare to our average? Well, both of those are above the average of 6.89. So checking in again with the exact language of the question, we're trying to see whether this number of lanes is above the average, and indeed it is. So for this question, we would answer true. So next question, true or false? There is a negative correlation between the number of self-check unlimited lanes and the average customer age. So let's pause a minute and talk about negative correlation. What that means is that as one of your trends goes in one direction, the other goes in the opposite direction, right? So as age goes up, we would want this number of self-check unlimited lanes to go down, right? Or vice versa. A positive correlation is when they both go in the same direction, right? So either both things go up at the same time or both things go down at the same time. So because we're looking for that negative correlation, we're just trying to make sure one goes up, one goes down. So let's, again, I think it makes sense to sort by customer age, so that will give us that nice sense of what is going up, which is our customer age. And then we're looking at this other column, the self-check unlimited lanes, and just seeing, hey, what happens, right? As age goes up, what happens to this number of lanes? Well, you can see that we start with some pretty high numbers, and then we end with some pretty low numbers. So just based on that, it does look indeed like as age goes up, our number of lanes goes down. That's our negative correlation. Just to give you one more way of thinking about it, you can also use that average, 3.56, to kind of think through this correlation. If we look at where these things fall in relation to that average, those first several stores, right, with the younger ages, all fall above our average, right? And then most of the stores in that bottom half where our ages are old fall below the average, right? So that's just another way of showing like, hey, we go from high to low, and then our other data point is going in the opposite direction. So because we've got that opposite directions, we can say that there is a negative correlation between these 2 columns, and that would make the answer for this one true. And the final question, true or false, stores in this table that have fewer self-check express lanes than the chain-wide average are less likely to have restaurants than stores that have more self-check express lanes, man, that's a mouthful, than the chain-wide average. So lots of details going on there, but what we are dealing with is these self-check express lanes, right? And we're particularly looking for a dividing line. Which ones fall above the average, which ones fall below the average. And then we want to look at how likely is it for those particular restaurants to have those particular stores to have a restaurant. So what I've done here is I have sorted by the relevant column, the self-check express lanes. So we've got low to high going there, and what I'm looking for is where is that dividing line, right? Who falls above the average and who falls below the average. And you can see that the dividing line is right there after those first three stores, right? I, H, and C are the only ones that are below that average. Everyone else is above the average. Now I'm shifting over to look at the restaurant column. How likely are these stores to have a restaurant? Well, all of those stores that are below the average have a restaurant, right? And then looking a little bit down in that column, much more of a mixed bag, way less likely to have a restaurant if you are above the average. Now, let's go back to the question itself and just double check with the language. This question says, the stores that have fewer self-check express lanes, so those first three, are less likely to have restaurants. But as we can see, no, they're way more likely to have restaurants, right? So because the exact opposite is the truth, then we can go ahead and say that the answer to this question is false. So as you can see, the table itself is pretty self-explanatory, not too confusing, nothing there to intentionally try to trip you up. But what can get you is that language, right? So paying attention to stuff like, okay, negative correlation, what does that actually mean? And in this third question, there's just a lot of detail of the language. So it's definitely good to double check to make sure that you're actually looking for the right thing. So that is that question. And I'll go ahead and throw another example up on the board. As always, take your time and then we will talk about it. All right, let's talk it through. So again, here we've got some text, and that's where I'm going to start. I just think it's the easiest way to kind of gain that toehold into the question and understand what this chart is saying. So that text tells us that we've got these 12 new home addition and renovation projects, and these are in competition for inclusion in a reality program. So that is exciting for these particular homes. So in order to determine who's going to be in that project, they are going to choose among these various features. We are also told that there are 4 city sections, so that's good to know, as we go through our question. Looking at the chart itself, we've got the address, the builder, city section, and then these sort of more numerical values regarding each house. All of that seems to make sense. So let's talk through the questions. These are yes/no questions, and we are said that we are to select yes if the statement must be true, given the information. Otherwise, we select no. The first one says, if the 5 with the highest ratings are selected, then one builder and one city section will not be featured in the program. So what makes sense here is to sort by rating, and then we know that we're dealing with the ones with the top 5 ratings. So that's what we've got here. Those ones circled in blue are the 5 rows that we care about. And we are then supposed to determine whether just one builder and one city section will not be featured. In other words, will be left out. So let's start with the builders. First thing I'm going to do is just see how many builders we have overall. So it looks like we've got Pitts, Accurate, Dexter, and BuildRight. So we've got 4 total builders, and we are just trying to see within these first 5 rows, are 3 of them in and then 1 of them out. So let's check it out. Sure enough, we've got Pitts, Accurate, and Dexter in those first 5, and BuildRight is sadly left out. So far so good. But we also need to talk about city section. We're looking for the same thing. We want 3 that are in, 1 that is left out. But if you look at it, we actually have all 4 of those city sections within these first 5 rows. So because we don't have one of those city sections left out, the answer to that first yes/no question is no. Now, our second question, yes/no, selecting the top 2 and bottom 2 by price leaves out exactly half of the city sections and half of the builders. So here what I've done is I've sorted the chart by price, and then we know that we are dealing with those top 2 rows and the bottom 2 rows. And we are just trying to determine whether we will leave out exactly half of the city sections and half of the builders. And we already know that there's 4 of each. So what we're looking for is, are we dealing with 2 builders and 2 city sections? And if you take a look, yep, city sections, we've got Southwest and Northeast that are in, and that leaves 2 that are out, so that's perfect. And then same thing with our builders. We have BuildRight and Pitts that are in, and we are leaving out the other 2 builders. So everything is perfectly true on that one. So our answer is yes. And then finally, we have selecting the top 3 and bottom 3 by square footage leaves out exactly one of the builders entirely. Very similar question to what we just got, except now we are dealing with square footage. So we'll go ahead and sort by square footage, and we know that we care about those first 3 and the bottom 3 rows here. And we want to see whether that leaves out exactly one of the builders. So go over to the builder column and see who we've got. We do have Pitts and Accurate in those top 3, and then we also get Dexter in that very last one. But who is left out? BuildRight, sorry, is left out. So that is exactly what we are looking for, and our answer to this question is yes. Let's do one final question, one that's slightly harder. So take your time working through it. Be careful with choosing your path, and then we will chat it through. Okay, let's talk it through. So here we are given a title on the chart, so I think that's a good place to start. It says the number of kilometers between clients. So we've got these clients who are creatively named A through F, and then we've got these numbers that seem to be how far away they are from one another. So going to the text, we see that Jorge travels to meet once daily with exactly 6 clients, clients A through F. When scheduling these meetings, Jorge schedules the most urgent meeting to be the first of the day, and then schedules the subsequent meeting according to which client is the least distance from the meeting immediately prior to it. Makes sense, right? I think Jorge's got a good plan here. So he is first meeting with his most urgent client, making sure that he for sure meets with them that day. And then from there, he's thinking about efficiency, right? So from that most urgent one, who's closest? From that next one, who's closest, etc. down the line. So all of that makes sense. Now, taking another glance at the chart itself, let's just see if we can get anything out of this. Let's start with client A. On that first row, we see kind of all these distances between client A and the other clients. And notably, the distance between client A and client A is 0 kilometers. That totally makes sense, right? So that's one location. But then if you wanted to go from client A, let's say, to client B, it would be 7 kilometers, just moving along that row. So that all seems to track. I think I have a good understanding of the chart itself. Let's see what the question is asking. So we have a yes, no little question box here. And it says, on Tuesday, Jorge's most urgent meeting will be with client E. That tells us right off the bat that he's going to go to client E first, based on the rules that we just read in the text above. So for each of the following pairs of clients, select yes if Jorge will schedule meetings with the given clients in the given order. Otherwise, select no. And then we're given these kind of pairs of clients and seeing, are they in the correct order or not? Now, I think it's clear that he starts with E. It's kind of hard to say right off the bat after that, like how does B and C, how do they come along in the order? I can't really see that immediately. What makes sense to me here, we've only got 6 clients. We know exactly how he is making his decisions on who to go to next. So I'm just going to set up his entire day, right? See what his entire order is. And then I'll come back to these particular pairs and see whether they're in the correct order. So let's go ahead and do that. Since we know that he's starting with E, let's sort the chart by column E. And again, between client E and client E is 0, but he's already met with client E. So who does he go to next? Well, the very lowest number there is to go to client A, only 2 kilometers away. So we know for a fact that he starts with E, and then his next client would be A. Now he's at A, so let's sort by A and see who is closest. Well, he has not yet visited F. F is only 1 kilometer away. So he would go from E to A and then to F. And we'll just rinse and repeat. We are now at client F. We have already been to client A, so we can't go back there. Next closest is client B, so he'll go to B. Now we're at B. Where's he going to go next? Well, he's not yet been to C, and C is only 2 kilometers away, so he'll go to C. And then he is at C, and we've already been to B, we've already been to A, but we have not yet been to D, and D is only 3 kilometers away. So that is who he will visit next, and that is our entire order, right? We have E, A, F, B, C, D, and that's his entire day. From here, this is very easy now to just look at those yes, no's and see, is this reflected in the order that we just came up with? So does he go from client B to client C? Yep, that's the exact right order, so that would be a yes. Does he go from C to D? Again, yep, that is exactly what we just found out, so that would be yes. And then finally, does he go from D to A? Well, no, he meets with A much earlier in the day and then goes to D at the end, so that one would be a no. So there are other ways to work through this question, right? There are other ways to kind of read the tea leaves here on this chart. But I think it is so much easier just to use that iterative sorting, right? And just to know exactly what's happening all the way through. And then it makes your life so much easier when you get to those yes, no's. So here, right, I think it is worth the time to do that upfront work and then only really address that yes, no box at the very end when you've already got your answer in front of you. So that's the end of our examples, and this has been table analysis for the data insights. Big takeaways, big punchlines here. First and foremost, give yourself time to understand the chart before you dive into the questions, right? So that might include reading the title, reading the text, and then just glancing at the chart itself to make sure it all makes sense. Second thing is that sorting is your friend, right? So use that sorting tool to be able to say, this is how you want to organize that information. You don't want to be kind of trying to scan and tally a bunch of stuff. So stay organized by using sorting. And you might need to sort multiple times, right? So like in this question, much easier if you just sort it, as you go by each client. So be flexible and creative with how you are doing that sorting. And then finally, probably most importantly, the reason why students miss these kinds of questions is usually not because of the chart itself being too confusing. Most of the time, it is because they get tripped up in the language of the question itself, or maybe the text explaining the chart, but basically just not getting all of those details of the language and answering the wrong question. So take your time, be careful as you are reading those details, and make sure you're answering the right thing before you get too far along. All right, this has been Dana with GMAT Ninja. I hope you've enjoyed this video, and I'll see you on the next one.